So welcome all in the class. Earlier we were describing the steady state stability and stability in general, how it is affected with the inertia and other factors. While describing the stability, we told if the disturbance is small, we do the dynamic analysis, and if the disturbance is large, we do the transient analysis. In case of a previous studies that described in the steady state analysis, we described the equal area criteria also, that without actually solving, while discussing the stability, stability is represent, or you can say well studies with the help of the swing equations. Swing equation you already know what is the swing equation you derived, and from the swing equation you obtained that in the equal area criteria, even without solving the equation, we can find whether the system will be stable or not. But if we want to find exact how delta and time are related with each other, what is the if the disturbance come, there is a oscillation around the normal position. Normal position may be the same as the initial original position or maybe different position. Say your generator is working at a 30-degree angle. After disturbance, it may happen again the system may work at 30-degree or another normal position of 40-degree. So both are the stable position where it may work. But 30 to 40, if it is reaching to 30 to 40-degree or 30-degree itself, it is not at all at fixed angle. It moves, it oscillates around the normal position, means around either 30-degree or 40-degree, whatever be the case. So when it oscillates around that degree, 30-degree, that angle of rotation, then means angle between rotor and rotating flux is 30-degree, and with the end rotor is rotating with the synchronous speed. Around the synchronous speed, at the point of 30-degree, it is oscillating with some frequency, and this we have to see what is the frequency of oscillation and what is the magnitude of oscillation. So this is our concern. What is, because magnitude is important. If it is oscillating with the high magnitude, it means a lot of hunting, lot of problem will be there in the system, lot of harmonics will be there in the system. Similarly, if the frequency is, and frequency also matter, at what frequency it is oscillating, it is super synchronous or subsynchronous frequency, and in addition to that, in how much time these oscillations are damped out. This is also important. So means time of oscillations. So the three things are important while studying this. Now, in case of a dynamic analysis, as we have seen, while we study the dynamic analysis, we will see the swing equation. This is the swing equation: Pm minus P is equal to mv square by delta T square. Here we have considered there is no resistance in the circuit, only the reactance is there. So there is no damping considered. Otherwise, this swing equation we told it is Pm minus Pe m d square by delta T square plus d delta by dt. It is the complete equation. But here we consider no resistance. So, or you can say neither resistance, no any other type of damping effect is there. So the system is unregulated. But in fact, the rotor is having the damping winding also. Rotor is having damping winding. It means the winding of there is a field winding in the rotor, there is a damping winding in the rotor. Damping winding, role of damping winding is to damp the system, and means whenever there is a change, because during the disturbance, rotor and rotating flux, they are not synchronized to each other. When they are not synchronized, it means there is a relative motion between the two. Because of the relative motion, there is induced EMF in the damping winding, not in the field winding. In the damping winding, because damping winding are the short circuit windings. So, and during that time, it behaves as an induction motor, and it tries to damp out the system. Means it opposes the cause by which it is produced, and accordingly, it damp out the system. But here, first of all, we will consider while describing this dynamic analysis, we will take few cases First of all, completely unregulated system. There is no damping in the system. Then we will consider the effect of the damper winding. Then we will consider the effect of the governor action. You know, whenever suddenly say load is increased, if the load is disturbance may be type of increase or decrease of load, because as I told in the dynamic analysis, disturbance is small. Disturbance is small, maybe say hardly 10% or 5% or 15% change in load. So that disturbance, and you know, whenever and in case of a large disturbance, there is a fault. Where fault is considered, then we can say there can be 100% change in load. If it is short circuit, then what will happen? No output may be there. Or so it is a big and large disturbance, that may be considered as a fault. But here we are considering the small disturbance in dynamic analysis. That's why uh, we may consider a small disturbance, 10% or 15%, and we know during whenever there is a change in load, the governor also come into the picture. Means initially, if say load become 100 to 110 megawatt, then governor senses and it allow to flow the additional fuel so that it can be covered. Means additional load can be taken care of by the extra fuel entry in the turbine. Then what is the effect of AVR, automatic voltage regulator, on the stability? That all these things, all these cases will be studied today. And first of all, let us have a completely unregulated system like this. Here you see, this is the curve this is the curve power equation. Power is equal to EV by X and delta. So this is the curve. EV by X can be considered as a P max. This P max, EV by X can be considered is a constant. E is constant, V is constant, and X is constant. So that is a P max, and this value is the P max and sine delta. P max sine delta. This is the curve. Means power, if the angle between rotor and rotating flux is delta 0, it will give the electrical power. It will draw the electrical power equal to this. If the power angle is delta, then it will draw power equal to this. And this power is supplied from the mechanical side. So this is mechanical power or generator power. This power is generated, then it is supplied to the load. So this is a mechanical power, this is the electrical power, and this is the curve. Okay, is there any question in this up to now? यहाँ से लेके अब तक जो बताया उसमें कुछ पूछना है, कोई क्वेरी है? एनी क्वेरी?
No, sir.
Okay. As I told in dynamic analysis, this disturbance is small. Means say you are working at delta 0, suddenly disturbance came out to be delta PG. Means delta additional power, additional mechanical power entered into the generator. So this additional power, this is small. So in this small period, we can consider it as a linear. If the change in disturbance is high, say if this power become from PG0, it becomes here, then this is a linear. We cannot consider as a this cannot be considered as a linear. It is a non-linear. So here disturbance is small, only 10% disturbance. That's why this portion can be considered as a linear. Okay, and this is the swing equation. PM minus PE, and you know PE, as I told, P max and delta. And at steady state when there is no disturbance, then it is drawing the power at a power angle of delta 0. So at delta 0 means P max and delta 0. Here, this is a P max and delta. Initially, P max and delta 0 power is being taken, and the same amount of power, mechanical power, is being supplied. Mechanical power, that is, you can say PM or PM0 is equal to P max and delta 0 initially. So this is the initial condition. So you can say PM or PE0 means at power angle delta 0. It is a P max and delta 0. And general equation is this. PE, what is PE? Is P max and delta. So this is a general equation. At any angle of delta, this is the equation. Now delta changes. Delta can be any angle, delta plus del delta. Because of this, because of additional load, because of additional input supply, power angle will rotor will accelerate. Because of the additional supply, rotor will accelerate and delta will try to change. Let delta is equal to delta 0 plus del delta. Delta की वैल्यू अब चेंज हो रही है, delta 0 plus del delta. तो del delta यहाँ से ये धीमे धीमे ये यहाँ तक चेंज होगा, and it can oscillate around this point, and finally new delta will obtain. It will be new delta. So you can say now new delta will be delta plus delta 0. This is variable. So in place of delta, you can write delta 0 plus del delta in place of delta, because this is general value of delta, and this delta can be delta 0 plus delta, means initial value of the power angle, and because of this changing value. Finally, the delta will not be there, only the fixed value. This will be finally fixed value. Say it become 5 degrees, so it was a 30 degree. So 30 finally delta will be 35 degree. But this delta is variable. Because of the delta there is oscillation. Change in delta will be continuously there, and after some time it will be stabilized. Del delta will be fixed value. So this initially PM mechanical power. What is the in place of delta, we have written delta 0 plus delta, and here also we have written delta plus delta 0, and input power is this. So here, if you now open this is Pmax sin delta 0. If you open this, because delta has changed, PM is fixed, only delta has been changed, then what will be the effect? So this Pmax, if you sin delta, sin A plus B, you can say sin A cos B plus cos A sin B. So this is Pmax, you can say sin A sin delta 0 and cos delta. As we assume del delta is small. Del delta is small, so cos 0 is equal to 1. Or if delta, consider delta is small, so cos del delta, cos 0 is equal to 1, and sin A cos B plus cos delta 0 plus sin del delta. And sin del delta is equal to del delta, because if delta is small, sin 0 is equal to 1 होता है, sin delta is equal to delta. So this is a delta. Is there any question up to now? इस इक्वेशन में किसी को कुछ पूछना है? No?
No, sir.
Now you see. So if you keep what consideration we have done, what is the assumption we have assumed, because of the small delta, sin delta is equal to delta is written, and cos del delta is equal to 0. So here this is the case. Now if you open this and this will be cancelled, and it will, this minus Pmax cos delta 0, if you bring on this side, this equation will come. Okay, and this Pmax cos delta 0, this is called the synchronizing power coefficient. Why? यहाँ पे आप देखेंगे पावर Pmax cos delta 0. ये what is this? Pm is equal to, if you see here, this is a power equation. This Pm is equal to Pmax cos delta. Differentiation of this is the Pmax cos delta 0. And delta differentiation cos delta 0 means it is the differentiation of this. So it is the slope of that curve. ये जो आपका कर्व है इसका स्लोप है. This is the slope of that curve. So this Pmax cos delta 0 is the slope of the curve, and it is called the synchronizing power coefficient. If the delta 0 is small, suppose for example delta 0 is if it is 0, so this is maximum. If this is 0, synchronizing is maximum. If it is 90 degree, synchronizing is minimum. मतलब क्या हुआ? अगर पावर एंगल जितना कम होगा उतना सिंक्रोनाइजिंग पावर कोफिशिएंट मैक्सिमम होगा. मतलब क्या हुआ? रोटर और रोटेटिंग फ्लक्स के बीच में जो कपलिंग है वो मैक्सिमम होगी. उनके बीच में कपल टाइटली, दे विल बी वेरी टाइटली कपल्ड. और जैसे जैसे डेल्टा 0 बढ़ता जाएगा, मींस अगर आप ऑपरेट कर रहे हैं 90 डिग्री पे, तो जरा भी डिस्टर्ब हुआ उनके बीच में मैग्नेटिक कपलिंग वो मिनिमम है, एंड दैट मे कॉज द instability in the system. Now, so okay, in place of now Pmax cos delta 0, we write it as a PR. PR is the synchronizing power coefficient, which is a constant value because it is a Pmax cos delta 0. मतलब जितने पे पहले काम कर रहा था, इनिशियल डेल्टा 0 पे ऑपरेट कर रहा था, उस समय इसका सिंक्रोनाइजिंग पावर कोफिशिएंट क्या था उस समय उसकी, क्योंकि जो कपलिंग थी, जो इसकी मैग्नेटिक कपलिंग था, उसी के अराउंड इसमें डिस्टर्बेंस हुआ है. नाउ dy delta is considered as a, now we take the Laplace. Why we can take the Laplace to solve this equation? This is a second order differential equation. We can solve it by the Laplace because we assume as a linear system. Laplace is applied to the linear system That's why otherwise there is a technique of solving the non-linear equations, and since we assume the linearized, so we can take the Laplace of this. D by dt is the s, so d square by dt square you can write it as s square. Okay, this delta here and del delta here is taken out. This is the PR synchronizing coefficient. So from here you can say ms square plus pr is equal to 0. From here you can write s is equal to this minus pr by m under root. Okay. So now there are few cases. Now there are two cases here, that if PR means synchronizing power coefficient is positive. If PR is positive, PR positive कब होगा? When the PR will be positive, you see PR will be positive when we are working in this direction, because PR is nothing but P max cos delta 0. So cos 0 is equal to here 1, here 0. So from here to here it will be positive, here it will be negative. So now, yes. So let PR is positive means we are working in the 0 to 90 degree. So this if it is a positive, then minus under root of minus 1 is equal to j. Under root of minus 1 will be plus minus j. So this s is equal to this. And we know what is s. In the Laplace, s is equal to j omega. If there is a no resistance in the system, s is considered s is equal to j omega means so in place of right, if you write j omega, j will be cancelled, and this will be omega n, natural frequency of the system. It is not the power frequency, it is natural frequency of the system. So it means omega n. It will omega n means PR. PR is the synchronizing power coefficient. जितने पे वो काम कर रहा था इनिशियली और उसका इनर्सिया था, उसके अकॉर्डिंगली इसमें नेचुरल फ्रीक्वेंसी आएगा PR बाई m. और उसमें क्या होता है नेचुरल फ्रीक्वेंसी? अगर सपोज करिए आपके पास एक लोहे की छड़ी है और उसको आपने जमीन में मारा, तो किस फ्रीक्वेंसी पे वो ऑसिलेट करेगा? अंडर रूट के बाई एम होता था उसमें, के बाई एम स्प्रिंग कांस्टेंट, और ये एम बाज द and here it is a PR by m. So it is the natural frequency of the system. Means now, and this is the omega and natural frequency of the system. इतने frequency पे ये it will be sinusoidal, and delta natural frequency of means oscillation will be like this. Delta will oscillate like this, and with the frequency, इसका जो भी frequency है, that will be given by this equation. PR by m. Now, to know the now if this s is equal to this means there are two, so s is equal to under root PR by m. So इसमें दो प्लस माइनस दो सॉल्यूशन है, s is equal to j omega, j cancel, plus minus PR by m. So you can say if it is a s1 or s2, there are two, so we can write the equation of delta is equal to a1 e to the power s1t and a2 to the power s2t. दो s की वैल्यू आ रही है, तो डेल्टा का सॉल्यूशन इस तरह होगा जैसे हमने करते थे, a e to the power minus a t by a e to the power minus a t by tau. तो उसी तरह इसको जो सॉल्व करेंगे तो इसका डेल्टा के लिए इक्वेशन बना. So del delta is equal to a1, in place of it is plus j omega t, it is minus j omega t, and this can be solved. J omega t can be written as a e to the power minus jx will be the cos x plus j sin x. Here cos x plus j sin x. So cos will be cancelled and it will be the sin. तो इस तरह से फॉर्म आएगा, एंड a1 plus a2 स्क्वायर का अंडर रूट विल बी दी दिस a0. इसको सॉल्व करने, इसको फर्दर मॉडिफाई करेंगे, देन इट विल बी a0 sin ओमेगा एन टी. मतलब क्या हुआ, यहाँ से हम ये निकाल सकते हैं, दिस विल बी द मैग्नीट्यूड एंड दिस विल बी द फ्रीक्वेंसी, एंड फेज डिफरेंस इज नॉट इम्पोर्टेंट हियर, बट whatever may be, it can be calculated. So it means the equation here we are concerned how much magnitude will be there. If the disturbance comes, if the small disturbance come, then what is the magnitude and what is the frequency? Since we have considered here no damping in the system, means resistance of there is no damping winding effect, resistance of the system is also zero. That's why we can consider the oscillation will be continuously there. Sinusoidal oscillations are there, but in fact there is always some resistance in the system. It's because of its natural resistance of the system, these oscillation delta, they will be decaying. It may take some time to decay, and finally, depending upon the resistance, there will be time constant. They will be decaying in according to with that time constant. And even if the resistance of the damping winding is not there, even then they will be decaying because of the natural damping of the system, natural damping because of the natural resistance of the stator and because of the friction. So that will be decaying. But anyway, we can consider if there is ideally there is no resistance, there is no damping, the oscillation will be continuously sustained oscillation may be there. So this is about, we can find what will be the magnitude and what will be the frequency of oscillation if the small disturbance came into the system on the stator side. Then, okay, now, is there any question up to now? Now, here, as we consider PR is positive, here if you see, we have considered this PR is positive. If we consider PR is negative, negative means in which area? PR is negative means if we are working, when PR will be negative? PR will be negative if we are working here, because PR is nothing but cos delta 0. Cos delta 0 means say we are working at this point. Here we are working say at this point. This much amount of power is taken and we are working at this angle. Suppose it is a 150 degree, then PR will be negative. In that case, if PR is negative here, so negative will be positive and S will be PR by M. Here S will be the, sorry. So yeah, so then S will be, this will be positive and S will be plus minus PR by M. And S is, if S is this, then the solution of this S will be A e power, here you see, here if it is a negative, this will be positive, S is equal to PR by M. Now, if PR, S equal to, this is not there, plus minus, S equal to PR by M, then only one, S value of S is equal to 1, then del delta will be A e to the power minus this T. Here S is equal to this e to the power ST. A e to the power S into T. So PR by M. And since it is a positive, no sign, so if you draw this, this will come. Delta 0 will be like this. Means not delta 0, delta, change in delta. This is the initial value of delta 0, and in fact change in delta is on this curve. So change in delta means around this there will be delta. So change in delta will going on increasing, means जो हमारा net value of delta है, delta 0 30 40 ऐसे continuously increase होता चला जाएगा, and finally the system will be unstable. So in this case, when PR is negative, the system will be unstable. Continuously delta will go on increasing 30 40 50 90 and finally 180, and it will lose the synchronism. Then system will lose the synchronism, means system will be unstable. And if PR is positive, synchronizing power coefficient is positive, then there will be sustained oscillations in this. In the rotor will have the oscillation around the normal, new or normal operating point. Now, okay, इसमें कुछ पूछना है? Anybody want to ask anything in this? कुछ पूछना चाहते हैं इसमें? No?
No, sir.
No, sir.
Okay. Okay. So, there was some yes. Now, just see this. Earlier also we described this figure. It is showing the uh, figure 4 synchronous machine, where this is the stator winding, this is the field winding, and here in the rotor there is a damper winding. Here in the rotor there is a damping winding, and they are short circuited. Short circuited means this is say front end and back end is here, so they are short circuited from front to back. And from means they all this and this also circuited from front and from the back also. So this is the damper winding, and damper winding here you say it is represented by like this. Anyway, our intention is to just describe that if the effect of damper winding having the resistance, short circuit resistance is there, if the effect of damper winding is considered, as I described earlier, our swing equation will not be equal to Pm minus P is m d square by delta t square, but an additional term, this will be there, d delta by dt. So when there is an additional term, now as I told, if you see this, we will repeat the same thing. If you see this, we have, this was the equation earlier without the damping, and we have differentiated this, then this equation came. Here also to get the solution of this, to get the solution means uh, delta become del delta plus because of the disturbance, or this delta will not be equal to delta 0, but it will be delta 0 plus del delta. ये जो delta है जो normal operating से plus del delta. So here the additional term m d square by delta t square here plus ये there is a additional term here d delta by dt. So here the additional term d delta by d del delta by dt, an additional term will come. So you see here जब हमने डेल्टा की जगह इसमें डेल डेल्टा 0 प्लस डेल डेल्टा रखा है, तो ये इक्वेशन आया जो कि this is the equation is same, no need to explain this again and again because we explain this, only this additional term has came. इसकी वजह से डेल्टा की जगह डेल्टा 0 प्लस डेल डेल्टा रखा, this is an additional term. And if you solve this, everything will be same. Sin delta, if you open this sin delta, cos del delta, cos del delta, and sin del delta. Sin del delta is equal to delta, and cos 0 is equal to 1. If that is the case, that this equation will be. Only thing is this is the again from here to here the same equation which we described earlier. Only this additional term has came. ये एक additional term आ गया ये because of the differentiation of this, differentiation of del delta 0. Del delta 0 means it is a constant value, so this is 0, only d delta by dt, only this term will come. So again this equation from here everything was the same, only this additional term has came here. इसकी वजह से एक ही additional term यहाँ आ गया. Okay, I think there should not be any problem in this. Now d delta by dt is s square, and d delta by dt is equal to s. Here it is a complete s, not subscript. It is a s, and this is a pr. Delta is common. Okay, I think there should not be any problem in this equation. Earlier this ds was 0, otherwise this equation is the same. So when this ds was 0, you simply said s is equal to minus pr by m. But here now it is a quadratic equation. Since it is a quadratic equation, the solution of this will be s is equal to minus b plus minus b square minus 4ac by 2a. Okay, according to this quadratic equation, the value of s will be this. S की value ये है. Any question up to now?
No, sir.
So S is equal to this. This can simply written as a minus d by 2m plus minus this this minus. If you take minus outside, so under root of minus will be the plus minus j. So this will be here m, and this. If take the square of this and will go inside, so it will be pr by. It will be, you can say it can be written as a 4m square under this 4m square. So this 4m will be cancelled. So pr by m, and it is d square by 4m square. This you can write this s is equal to like this. When s is equal to like this means s is having 1. This is plus minus. So it is a two values s1 and s2. And s1 is minus d by 2m plus j under root of this. In case of a s2, it is a minus j of this. So this minus d by 2m can be written as a say alpha, and this can be written as a omega d. Omega d means otherwise this is pr by m as the omega n. Omega n minus something, it is omega d. Means so this minus alpha is called the attenuation, and this is called the frequency, damped oscillation frequency. एंड देखिए इसका सोल्यूशन ऑफ दिस, इट इज ए पावर माइनस s1t प्लस माइनस पावर s2t। उसी को सेम फॉलो, इफ यू फॉलो द सेम थिंग्स विच वी हैव डन अर्लियर, तो उसमें पहले क्या था सॉल्यूशन, ए डेल डेल्टा इक्वल टू ए जीरो साइन ओमेगा टी, यही तो था। देखिए व्हाट इज दिस, व्हाट इज द सॉल्यूशन हियर, it was the delta a zero sin omega n t plus psi this। now the solution of this only here minus alpha, अगर ये ओमेगा डी होता तो वही सोल्यूशन आता, ओमेगा डी टी, हियर माइनस अल्फा और है, एक एडिशनल टर्म है, सो दिस विल कम हियर माइनस अल्फा टी लाइक दिस, बिकॉज इसमें देखिए इसको जब हम लिखेंगे ई पावर s1t प्लस माइनस ई पावर s1t प्लस ई पावर s2t, a1 ई पावर s1t, a2 ई पावर s2t। तो ई पावर जब s1t लिखेंगे तो ई पावर s1 की जगह माइनस अल्फा प्लस माइनस जे ओमेगा डी, तो ई पावर माइनस अल्फा विल कम आउटसाइड, ई माइनस अल्फा हमारा मीन्स ये ई पावर माइनस ए प्लस टी, ए प्लस बी क्या होता है, ई पावर ए इंटू ई पावर बी। So e to the power this e to the power 80 will come out, otherwise it will be same. So this equation, if you plot this, इसमें क्या हो रहा है, e to the power अल्फा टी का मतलब क्या, डिकेइंग है, इट इज ए डिकेइंग फंक्शन, ये साइनोसॉइडल फंक्शन, इट इज ए डिकेइंग फंक्शन। So if you plot this, then delta means delta 0 plus delta, net delta will be like this, delta will oscillate, means the frequency of oscillation will be omega dt, and it will damp out, in certain period of time called the damping constant and frequency, and this is the initial magnitude। starting में magnitude ये हुआ, means initial magnitude is the omega 0 and it will continuously to decaying with the decaying constant of e power alpha t, alpha means t by tau, tau is the time constant, so time constant means tau is equal to 1 by alpha, or you can say tau is equal to 2m by d, according to 2m by d इसका m इनर्शिया जितना ज्यादा होगा उतना जल्दी डिके करेगा, और डैम्पिंग जितना कम होगा उतना जल्दी डिके करेगा, सॉरी हाँ, so damping, so accordingly if damping is more, it will damp out। so this is now oscillations। is there clear or not this equation? yes please मितेश,
यस सर।
क्लियर है या नहीं है?
यस सर।
now we will take the effect of governor action। देखिए हमने लोड फ्रीक्वेंसी में ये क्या था, अब तक ये एज्यूम किया लोड बढ़ गया, इलेक्ट्रिकल लोड बढ़ गया या कम हो गया तो सिस्टम की में जो ऑसिलेशंस आएंगे वो किस टाइप के आएंगे। इसमें हमने ये एज्यूम किया है हमारा गवर्नर एक्शन काम नहीं कर रहा है, केवल थोड़ा सा लोड बढ़ाता और ये अपने आप कैसे उसको सस्टेन करेगा। इनफैक्ट हमारा गवर्नर एक्शन भी काम करता है जो हमने लोड फ्रीक्वेंसी में पढ़ा हुआ है। गवर्नर एक्शन का क्या, जैसे ही लोड बढ़ेगा तो फ्यूल की एंट्री बढ़ेगी, या लोड कम होगा तो फ्यूल की एंट्री कम होगी विद सम टाइम डिले। टरबाइन और स्पीड गवर्नर के टाइम डिले के अकॉर्डिंगली और उसमें इंटीग्रेट करके पता लगते हैं कि कितना हमारा फ्यूल एंट्री होगा। सो एंड वी नो दिस पीएम। अभी तक क्या किया था, पीएम हमने कांस्टेंट माना था कि पीएम इज नॉट चेंज, ओनली इलेक्ट्रिकल साइड में लोड चेंज हो गया, पीएम उतना ही है, तो हमारे स्टेबिलिटी पे क्या फर्क पड़ेगा। नाउ अब हम देख रहे हैं कि जैसे ही आपका इलेक्ट्रिकल लोड बढ़ेगा पीएम भी चेंज होगा। पीएम कैसे चेंज होगा, स्पीड गवर्नर उसे सेंस करेगा तो भाई लोड बढ़ गया है, तो स्पीड गवर्नर जब सेंस करेगा तो आफ्टर सम टाइम ऑफ सेंसिंग टाइम इट विल बी द फ्यूल एंट्री विल बी चेंज। और फ्यूल एंट्री कितना, जितना हमारा देखिए फ्यूल एंट्री कितना हो रहा है, जितना उसने रोटर की स्पीड, जैसे ही आपका इलेक्ट्रिकल लोड बढ़ा रोटर की स्पीड चेंज होगी, रोटर की स्पीड को सेंस करके उसी के प्रोपोर्शनेट ही फ्यूल चेंज करता है। स्पीड गवर्नर के अगर आपको याद होगा, स्पीड गवर्नर में फ्रीक्वेंसी के प्रोपोर्शनेट ही हमारा फ्यूल की एंट्री हो रहा था, चेंज हो रहा था। सो से पहले पीएम 0 था, अब पीएम 0 की जगह पीएम माइनस अल्फा। इनिशियली अगर सपोज लोड कम हो गया तो पीएम की वैल्यू भी अकॉर्डिंग टू दैट अल्फा इज सम कांस्टेंट, दिस अल्फा इज नॉट द ये वो अल्फा नहीं है जो ये वाला है अल्फा, दिस इज नॉट, d/2m है, डैम्पिंग से रिलेटेड है, दिस अल्फा इज डिफरेंट, दिस अल्फा इज डिफरेंट, लेट इट बी से ए बी सी, कुछ भी इसको आप एज्यूम कर लें, और यू कैन से इट इज ए, ये ए है और ये अल्फा है, ऐसे एज्यूम कर लें। सो तो जितना आपका ओमेगा में चेंज होगा बिकॉज ऑफ द इमीडिएटली इनकी जो डिक्रीज ऑफ द लोड, जो स्पीड में सेंस होगा, स्पीड के सेंस के अकॉर्डिंगली इसका PM0 मैकेनिकल पावर चेंज होगा। तो अब जो हमने एज्यूम किया था PE0 कांस्टेंट था 30 डिग्री पे, या इनिशियल पावर एंगल के अकॉर्डिंगली ही PM0 था या PE0 था। अब वो PE0 नहीं रहेगा, बट इट विल चेंज बाई PE0 माइनस अल्फा प्लस डेल ओमेगा, ये इसमें चेंज आ गया थोड़ा, ओके, ये इसमें चेंज आ गया, ऑल्दो इट विल टेक सम टाइम, इसमें कुछ टाइम लगेगा, बट वी चेंज आ गया। तो ये जब एडिशनल चेंज आ गया तो देखिए ये यहाँ पे दिस इज सेम एंड PR बाई डेल्टा ये यहाँ से निकल के आया था, एंड डिफरेंशिएशन ऑफ दिस इज differentiation because this is a constant value, differentiation of this is 0 and this is minus alpha and del omega की जगह आपने delta by dt लिखा, we can write omega is equal to d delta by dt, so this term can be written like this। जो हमारा एक एडिशनल टर्म आया है, ये एडिशनल टर्म आया है, उसकी जगह हम इसको डेल्टा के फॉर्म में लिखेंगे, तो ये लिख सकते हैं। इस इक्वेशन को अगर सॉल्व देखेंगे तो यहाँ देखिए डी डेल्टा बाई dt का एक ही इक्वेशन है, डी डेल्टा बाई dt की इक्वेशन है। सो इफ यू ब्रिंग दिस इक्वेशन ऑन दिस साइड, दिस टर्म ऑन दिस साइड, इट विल बी d प्लस अल्फा, इट इज d प्लस अल्फा। तो पहले इक्वेशन क्या थी, इफ यू सी दिस इक्वेशन, ये इक्वेशन यहाँ पे आप देखेंगे, व्हाट वाज दिस, ये इक्वेशन आप देखेंगे दिस PM माइनस पी एम डी स्क्वायर बाई डेल्टा टी स्क्वायर प्लस डी डेल्टा बाई dt, यही तो है। सेम इक्वेशन इज देयर, ओनली इन प्लेस ऑफ d इट इज d प्लस अल्फा, या सेम इक्वेशन है, इन प्लेस ऑफ d इट इज d प्लस अल्फा, मींस ये किसके प्रोपोर्शनेट आ रहा है, फ्यूल, जितना हमने लोड बढ़ाया है, फ्रीक्वेंसी चेंज हुई है, स्पीड चेंज हुई है, उसके अकॉर्डिंगली हमारा फ्यूल एंट्री चेंज हुआ है। तो फ्यूल एंट्री गवर्नर एक्शन की वजह से, गवर्नर एक्शन की वजह से जो फ्यूल एंटर किया है उसकी वजह से d की जगह d प्लस अल्फा हो गया। तो अब इसका सॉल्यूशन क्या होगा, सॉल्यूशन विल बी सेम, नीड नॉट टू सॉल्व, यहाँ d की जगह d प्लस अल्फा हो जाएगा, d की जगह d प्लस अल्फा हो जाएगा। तो d प्लस अल्फा हो जाएगा तो इसका मतलब क्या है, ये वैल्यू था, ये वैल्यू अल्फा की वैल्यू ये बढ़ जाएगी, से अल्फा 1 अल्फा 2 कह लो इसे, तो दिस इज अल्फा 1 न्यू 1 इज अल्फा 2, तो यहाँ अल्फा 1 प्लस अल्फा 2 हो जाएगा। व्हेन इट विल बी अल्फा 1 प्लस अल्फा 2, तो इसकी वैल्यू माइनस, ये वैल्यू सपोज माइनस पहले वैल्यू थी, अब ये ज्यादा हो गई, तो इसका सोल्यूशन क्या होगा, डैम्पिंग फास्ट होगा, दिस डैम्पिंग विल बी फास्ट, अल्फा की वैल्यू बढ़ गई, टाइम कांस्टेंट बढ़ गया, तो ये हमारा डैम्पिंग फास्ट हो जाएगा। ये सपोज करिए ये सपोज करिए ये डैम्प आउट हो रहा है 10 सेकंड में, तो ये डैम्प आउट हमारा 5 सेकंड में हो जाएगा। And this is our intention and purpose. Whenever the disturbance comes, we want it should be damp out as early as possible. तो हमारा सिस्टम पे उसका नेट इफेक्ट ना पड़े, इसलिए हम जो डिस्टर्बेंस है उसको डैम्प आउट करना चाहते हैं। So this we have seen the effect of what is the effect, means we have seen the dynamic analysis and the effect of damper winding on this and the effect of governor action on this। कि डैम्पर वाइंडिंग कंसीडर करते हैं तो हमारा डैम्पिंग फास्ट हो जाता है, गवर्नर एक्शन करते हैं तो और फास्ट हो जाता है। एंड means whenever a small disturbance comes, now again you can see here, whenever this disturbance comes, सपोज करिए आपका इलेक्ट्रिकल पावर पहले डेल्टा 0 की जगह इलेक्ट्रिकल पावर ये बढ़ गया, तो ये इसमें न्यू पोजीशन ये ऑक्युपाई करने के लिए इट विल ऑसिलेट अराउंड दिस, द फ्रीक्वेंसी ऑफ ऑसिलेशन आपको पता लग गया, यू कैन फाइंड व्हाट इज द फ्रीक्वेंसी ऑफ ऑसिलेशन फ्रॉम दिस इक्वेशन, जो अभी आपने √PR/m ओमेगा n हो गया, और ओमेगा d के लिए भी आपने इक्वेशन लिखा है। सो यू नो द फ्रीक्वेंसी ऑफ दिस ऑसिलेशन एंड यू नो द मैग्नीट्यूड ऑफ ऑसिलेशन, यू नो द डैम्पिंग फैक्टर आल्सो, तो ये आपको पता लग जाएगा। सो आई थिंक दिस इज क्लियर अप टू नाउ? मुझे लग रहा है यहाँ तक चीजें क्लियर हैं. वी कैन कंसिडर वन न्यूमेरिकल क्वेश्चन ऑन दिस आल्सो, दैट इज आल्सो इम्पोर्टेंट कि if this amount of disturbance is there, what is the magnitude, what is the frequency? इसके लिए न्यूमेरिकल क्वेश्चन भी हम कंसीडर कर सकते हैं. लेटर ऑन वी विल सी द इफेक्ट ऑफ, अब तक हमने क्या डैम्पर वाइंडिंग का और गवर्नर एक्शन का इफेक्ट देखा है, एंड लेटर ऑन वी विल सी द इफेक्ट ऑफ एवीआर. अगर ऑटोमेटिक वोल्टेज रेगुलेटर लगाएं तो उस पर क्या इफेक्ट होता है, दैट वी कैन आल्सो सी. सो इफ यू हैव एनी क्वेश्चन अप टू नाउ, यू कैन आस्क द क्वेश्चन. इसमें अगर आपको कुछ क्वेश्चन पूछना चाहते हैं, देन यू कैन आस्क इट.